So I have been successful in printing consistently great looking and functional SLS parts over the past month using the Formlabs PA12 powder. So I decided to create a series of videos related to some of the key printer settings that made a significant difference in a successful print, both in appearance, dimensions, and tolerances. Now you may have different settings for your printer based on your build, the powder, and the components in your system. But these videos will explain the issue I was seeing and the settings that made a difference, so you have an idea of what settings to check. And by working with Thomas and Pavel, they were actually able to create new calibration tests as well as firmware and config file updates to improve the overall experience. So that's where we start from. Let me be honest with you. Printing SLS parts is hard because of the small window in which to operate to get the PA12 powder to lay down smoothly, heat up, center, stick to the powder bed, and then prepare for the next layer. I mean, a degree or two difference in temperature can make all the difference between a successful print that doesn't wipe off, or is warped, or has low density, or shows layer lines. And that's one of the great features of the Inova MK1 SLS printer, is that all the parameters are open, so you can make these changes and explore with your current print or just with other powders. Now, one of the issues I had during my first print failure that you all observed in my previous videos, when I got to the bed prep phase and the printer was laying the first 0.1 millimeters layers at the default temperature of 177 Celsius. And at that time, then my surface would tear catastrophically and ruin the print bed surface. So initially, Thomas and Pavel attributed that to the virgin powder I was starting with, as it tends to expand much more than a used new mix powder using a ratio of 70 used to 30 new. And part of that was true, that I'll explain later in another one of the settings. However, after these print failures, when I examined the powder, it appeared that the top layer was scorched or overbaked, giving it a crusty appearance. So it allowed the recoater to break it apart and basically drag everything attached to that layer across the print bed and wipe it off. So I just overall thought my system was set too hot for this powder, kind of in the order of 6 to 8 degrees Celsius. So as we were brainstorming, Pavel mentioned that maybe we should calibrate the thermal camera specifically for my system to see if there was any differences between what it was measuring compared to the real world temps. So because the thermal camera lens is protected by the yellow tinted zinc selenium glass, it obviously impacts the temperature that it visually detects. So there's a built-in setting for the thermal camera offset, and that adjusts for this temperature difference. Now by default it is 12.5 Celsius, and that setting is found here in the printer settings. Mine is now 17.7. But let's assume 12.5 was the correct offset for the thermal camera. Then, if we set the actual temperature to be 100 degrees on the powder surface, the raw data from the thermal camera would be reading 87.5. And with the offset, all values from the camera will now be adjusted to match the actual temperature. So 87.5 plus 12.5 is 100. However, without the offset, in this case, the thermal camera will read 87.5, and the software will tell the halogen lamps to keep heating until the thermal camera raw data says it's 100. But if it did that, then the actual surface temperature will now be 112.5 Celsius. So you can see now why the wrong offset in your thermal camera calibration can actually cause some headaches, like what I saw. So we decided to do a modified test that they use for new powders. So we put a layer of powder on the print surface and slowly heated the Formlabs powder in 1 degree Celsius increments. And we kept the default thermal camera offset of 12.5 for this test. Now Thomas indicated that we should see the powder darken using the video camera around its actual melting point of 187 Celsius. And then any difference of what was observed versus what was to be reading between what the thermal camera read would determine any additional offset needed. So in our test, my thermal camera was reading 181.8 Celsius when the powder surface darkened. Now, I don't have video of this because I was on a call with Pavel and it wouldn't let me record at the same time. But the test confirmed my suspicion that my thermal camera was measuring lower than real world temps, or in this case 5.2 Celsius during the bed prep phase, and frankly for all phases. Pavel has since created a new test during setup called the thermal camera final calibration that needs to be completed before you start printing. Now, by adding this additional 5.2 Celsius offset to the 12.5, my offset is now 17.7, and then I was finally able to get through bed prep with a little modification to the print stage.